Okay, this is the part 2 of the function lecture. So I would like to explain more about the range of a function, because in my previous lecture, like I mentioned that, let's say fx equals to x plus 3, where x must be smaller or equals 3, then f3 is just 3 plus 3 equals to 6. So we know that this is the what we call the input. This is the rule. This is the domain. Domain is the meaning of domain is what are the numbers that we can input into this bracket, right? So this domain tells us that we can only input numbers lesser or equals to 3 into this bracket. So what does it mean? That means that, let's say f4 is not valid. There's no such thing as f4 because 4 is greater than 3 and the domain is only lesser or equals to 3. So there's no such thing as f. That means, right, let's say if we were to draw a graph where this is x and this is fx. This means that when we input a value 3, what we get is a value 6 for f3 is equals to 6. So this is your f3. No, in fact, this is your f3, right? That's what it means. So we cannot input numbers that are 4, so that means there's nothing over here. So let's say if I input 1, what do I get? So f1 will be equals to 4. So that means this point will be 4. So on and so forth. So let's say if we have input 0, we'll get 0 plus 3, which is equals to 3. So we'll get a value over here, 3, right? So if we do this continuously, like for f1.5, then what I get will be 1.5 plus 3 will be equals to 4.5. So I get a value somewhere here. So if you see, if I join all these dots, right, what I get is a line. And in this case, it's a straight line because this is a linear function. As I mentioned, a linear function means that a function with a polynomial with highest degree is 1. Alright. So what then is this value? This value should be minus 3 because f minus 3 will give me equals to minus 3 plus 3 will be equals to 0. Right? This value y. So what does it mean when we say domain is this? So from the domain and the rule, we can derive what is the range of the function. So what is the range of this function? The range of this function is just the y values of this existing graph. That means the range of this function f is actually equals to all the way from negative infinity to 6. Right, because we input 3, that's why there is a 6. It comes out 6. Right, so and why is it negative infinity? Because we can keep putting in numbers that are lesser and lesser. So if we put in like negative 9999, then we get negative 9996 as the output. Right, and we can keep on going. Therefore, actually, this line has no end. It's going to go on forever. So the y values that comes all the way down will be negative infinity. So this is an interval notation, right? Interval notation as in like, okay, this is whenever it goes to infinity, is always a round bracket. When it is a square bracket, it means that the number is included. Right, the number is included. Why in this case 6 is included as part of the range? Because 3 is part of the input. This is smaller or equals to 3. So 3 is input into the function. Therefore 6 is an output of the function. If I change the function such that there's no smaller or equal, but strictly smaller than 3, then this interval will change. You will use the round bracket because it is up to 6 but does not include 6, right? Because I did not input 3, therefore 6 should not be part of the output. This is just 6, then 6 should not be part of the output. So this is just one point to take note. Then there might be some functions where there's a disjoint. Let's take it this way. Let's say if I have fx, right, maybe I use another alphabet to define another function, gx equals to 1 over x, where x is an element of real numbers. Now the input can be any real numbers. Okay, you can Google what real number means. I'm not going to explain it here. So that means this is the domain, or what values that you can input into the x of this function, and this is what we call the rule. And now we want the range. So what is the range? So let's say you can actually draw the graph, right? The graph of 1 over x is like this. So when x is 0, 1 divided by 0 is undefined, so we have a vertical asymptote over here. That means, but when it's a very small number like 0.1, you get 1 divided by 0.1 is 10, right? And the closer it gets to 0, the higher the value, so it comes down like this. So as x approaches a very large number, 1 divided by 100 for example, then it becomes 0.01. So as x gets larger and larger, the value of gx gets smaller and smaller. It doesn't touch the axis, right? It doesn't touch the axis. But you will go closer and closer to the axis, right? You give it a very large number like 99999, and you goes to a very small number, close to 0 but not touching 0. So you can 1 divided by even a very large number will be some number very close to 0 but not touching 0. So if I take minus 0.0001 as the input, then 1 divided by minus 0.0001 become like 1000, is it? Right, 0.0001. So positive. If 1 divided by minus, then will give me minus 1 0 0 0 1 2 3 4 4 zeros. Just want to make sure I'm right. 1 0. If minus 0.1 will give me minus 10. So yeah, 1 0 2 0 3 0. Yeah, correct. So in that case, when we do this division, right, it goes to here. Then when 1 divided by minus 9999, for example, if the number here is very large, like minus 9999, then you give me a very small negative number. As in, let's say if this is minus 10, right, then this will be minus 0.1. So you're going to get closer and closer, right? And if this is like this is minus 0.1, then this will be like minus 10. And as it get closer, it's going to this value going to get larger and larger. So we see that this is the graph of 1 over x. Then what happens to the range? You see, the range is the y values of the graph, or the vertical values of the graph. So you see that actually 0 is not part of the range. Gx equals to 0 is not part of the range. Gx is never equals to 0, in fact. So that means the range of g is equals to from negative infinity all the way closer to 0, but not touching it. Union 0 all the way to infinity. This is one way of writing. Or we can say that the range of gx is all real numbers excluding the value 0. Right, these are different ways of writing this. So that's the end of this lecture today.